Hey everybody, so in this video I'm just gonna be really quickly going over pretty much how to code on Roblox in like an object-oriented type of way. On Roblox specifically, it codes in a prototype-based object-oriented programming type of way. Now, I'm not an expert at all on this, nor should all the terminology I use may be a little bit messed up. So because I'm not an expert at this at all, but I'm gonna try to explain my best to newbies why object-oriented programming is a thing, why you should learn it yourself, and what are the advantages of using it is for. So let me backtrack a little bit. Let's go talk about procedural programming on Lua. On Roblox specifically, a lot of the programmers, 99.9% of programmers on here, use procedural programming type of ways to program. And that's fine. That is fine way of programming. The benefits of using procedural programming is that first, it's easy to start off programming that way. If you want to make something very simple, it's easy to program it. If you want I actually have a list here that talks about some of it. So, for example, it says procedural programming right here. So it says some of the advantages is you can jump right into programming. It says you can learn the language easy, which is also probably a reason that Roblox chose Lua as in language to as a code-based or as some type of language to start people off with, because Roblox is a platform. They want to encourage people to learn how to program. It's easy because you read from the top to bottom pretty much. And yeah, that's pretty much a lot of the advantages. Some of the disadvantages of it is that if you have a bunch of code, it can get very messy if you start having like functions call other functions, and it gets out of order, because then you got to look at this function and then go all the way to function A to function B, and just say function C calls function A again, and you forgot, so you have to go back to function A. Things can get a little bit confusing, and it's harder to break down code. And also, the thing about it is usually there's always going to be arguments and parameters. While in object-oriented programming, the more and more you use something called inheritance, the more and more you need less and less parameters and arguments. So I'm just going to explain what object-oriented programming is. I have an image here. So if we were talking about automotive, for example, cars and motorcycles, bikes, planes, automotive, stuff like that, we can, let's say we was just starting off with cars, right? We can specifically, we have cars here, we can specifically go a little bit vaguer with it. What's before a car? Then we get automotives. Same thing with motorcycles. What's a little bit more vaguer than motorcycles? It's automotive. We can call automotive different things. There's no one solution to a problem. But now we can get specific with these two. We can get specific with cruisers. We can get specific with sports bikes. Whoops, don't want to go there yet. And so on and so on. But as you could see, that the way this would work is we would have an object, which is hence object-oriented programming. An object called automotive. Okay? And this is also called abstraction a little bit. Actually, no, I'm sorry. This is not abstraction. Abstraction is something else. Sorry. Once again, I'm not a professional at this. I do not know the terminology 100%. But this is what we would inherit from. So when we create a motorcycles object, we're inheriting from the automotive object. So what does that kind of mean? So we could just create a motorcycle object, right? But everything inside the motorcycles object, like just say we have some variables and functions, automotive should already have them. We shouldn't have to declare it again in motorcycles unless we want to add on to it, right? So that's what makes it easy, is because car and motorcycle. So for example, a start and stop function should both of these should have the start and stop function, because they both can start and stop. So we should just make automotive have the start and stop function and just inherit from it. So we have cars and motorcycles that both have start and stop, but we can add on our own methods as well as to them. Same thing with cruisers and sport bikes. They may have their own properties for those as well. So that's when we get into like an object-oriented type of way of showing. This is how like a normal inheritance-based like object-oriented way of showing how objects are. An object usually representative of an object, like showing the representation of it, is usually just a box with the object name up top. And something you should learn is in object-oriented programming, stuff really aren't really called variables and functions anymore. They're usually called properties and methods when they're inside an object. So these are called properties, which are pretty much the same thing as variables, and these are called methods, which are just functions. So I show you here that we have the automotive and we have gas, speed, start, and stop. So we have gas property, a speed property, we have a start method and a stop method. And then as you can see with the car, we have those two, but we also add on the headlights method, which only a car can have. But a motorcycle can have it too, but I'm just going to show you showing you example of what specifically you can do. And then I go down here and I add the kill switch. So if you don't know what a kill switch is on a motorcycle, it's just something that's when the kill switch is on, that means you can't start it unless the kill switch is off. That's pretty much what it is. And then we can go down a little bit more. And now in the cruiser, we have the speed, gas, and a property called brand, start, stop, and kill switch. We inherited all this information from that. So this makes object-oriented programming makes it a little bit easier to understand code. It makes it easier to, it makes a lot of things easier, especially when you're going to code in groups with people. They're not going to really code in procedural ways, because procedural programming, if you have other people trying to understand your code, it's very, very difficult to do so, while if you did procedural versus object-oriented way. Now let's just get into the code. Let's try to create this. Now the thing about object-oriented programming in Roblox, it's a prototype-based object-oriented way. It's like a type of programming. In Java and C#, I believe, other different languages, they use classes. So you would have a class, but Lua does not have classes. It's oriented, so it kind of looks like tables. So let's create our first automotive object. It looks just like a table, right? In this, what we do is, if you don't know how tables work, you could pretty much say automotive.new is equal to let's just say automotive.new is equal to test, right? And I spelled automotive wrong. Right, so basically what that's doing is it's just saying new is equal to test. That's all it's doing. It's pretty much just doing this inside of it. But instead we're declaring it outside. We also could do it the bracket notation way. We could do it like that, and it's pretty much the same exact thing, right? We could do that as well in bracket notation in here. Like that. Doesn't matter. But the way we're going to do it is, just for showing, I'm first going to do it in dot notation for you. So as you know, in Roblox, anything with dot new pretty much is creating that object. So like brick color dot new, and then in here we have like the color we want, right? But the thing, it's not just a color. It's not just, you know, white. It's not just black. It's not just a color. They also have properties to them. So if I were to search up Roblox brick color dot, I think it's brick color 3.new actually. Nope, it's just brick color. You can see that it has these news. It has black, red, yellow, green. It also has some properties to it. As you could see, object-oriented programming, don't call them variables, they call them properties. You have a name, color, RGB, .r, .g, .b, and then we also have methods in here, which, well, actually, these are constructors. Anything with just a dot is pretty much a constructor. Dot palette, dot random. Well, actually, nope, sorry, yep, those are, and then we go into properties, which are still using dots, and then we'll go into methods, where they are, this may actually not have a method. What's a good thing that we can do? Blah, 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 blah. Part. Nope. Instance. It's not that much. I really can't think of a specific thing right now that I can show you that's like a method. Methods are pretty much the same thing, but they kind of use this notation instead. They use that with the colons. It's pretty much the same thing as calling, you know, dot new, but instead using that. But anyways, we would do that. But whenever we do this, usually with Roblox, it's a function. It's not really a string with dot new. It usually gives us back some type of table of information. So we'll just do function dot new, automotive dot new is equal to a function, and we can just type in now return. I'm not gonna get in explaining what this type of returning stuff is, because you should already know what this is if you want to learning object-oriented programming. Now we can return now a table here of information. So if I did prop1 equals to test, prop2 equal to test2, so on, and then if I did now if I did car1 is equal to, well, let's just call it some vehicle is equal to automotive.new, and then we try to print vehicle. We try to print this now, we're gonna get a table, because it's a table of information, right? If I did dot prop run, it's gonna do test, and it's gonna do test2 as well. See test. If I do test2 prop2, it would show test2. Basically that's how you kind of create objects, but as well as you could do methods as well. So you can create in here method 1 equal to a function, and we could just do print hi, right? And then if I did vehicle, and then let's just call it method 1 and do this, it says hi. Now I want to discuss the difference between using this the colons or the dot. If I do the dot, it'll say hi, right? So I might, if I do print self, let me see. No, right. So the dot method, what that does is actually, there's a keyword called self, right? Now, what that does is self is just talking about the table. So if I did self dot prop 1, this talks about what table it's inside of. So this right here, and then dot prop 1, which is this right here. If I did vector method 1, and I'm using the dot notation, right? This would give me an error, as you could see. But if I gave it vec, right, it should work, right? Yeah, see, it works. Now, this kind of gets old, just giving it itself all the time. That's what the colon's for. The colon kind of already invisibly gives itself, but we can't just leave it like this, because it wouldn't work like that. we have to put self in as a parameter all the time. And then if we did this, it would work flawlessly now. See, it talks about itself. This whole entire dictionary, I'm sorry, not dictionary, table, it talks about itself. Now, the thing about this is that we can do it this way. We could create this like this, but it's a little bit weird creating it this way. So what I'm gonna do is instead, I'm just gonna say new is equal to function and then return it like that. It's a little bit, it's the same thing, but it's just coded inside the table instead. And here is where I would have like properties I want to declare right away. Or you can declare them, sorry, not there, my bad. Here is where you would want to declare them, like var1 is equal to hi, let's just call them var1, and then you go to the second one, and so on, so on. Let's call this method1 equals function self. And actually what we can do is we can do self dot var2 is equal to var2, right? So what this does is it can create its own variable. So I'm going to show you, right? I did dot new, right? However, if I try to print vehicle dot var2, it's going to show a nil object. However, if I now do vehicle dot method, whoops, wrong thing, method1, and then print vehicle dot var2, we are going to get var2 as a string output. Now you can do dictionaries, whatever you want, you can do it all. Now let me delete that. Now there's something called static variables, which you would learn in object-oriented programming. Static variables are something that will always remain inside a specific object, but it's not. Objects are per creation. Every time you instance them, they're all the same. So if I were to do, if instead, you can also pass in stuff to this, right? So it's just a second. So if I did method1 and I do item, right? And we'll say var, let's just change this back to var1 and change this to item, right? And I put in some type of string here. We'll call this sweet, right? Well, actually, sorry. Dot new. This is where it would go. This is the constructor, so we'll do item here. Not there, sorry. And it would say var is equal to item. And let's just delete the code in there. And let's call this sweet. We can call another one vehicle 2. Let's call this awesome, right? We have these two. Now if I were to, let's do print var1, right? Self.var1, if we were to print it, if we were to do the method1 now, vehicle method1 and vehicle2 dot method1, we're going to get two different answers, sweet and awesome, because this is per each individual item. Now if I were to do after that vehicle2 dot var1 is equal to right, and then we do vehicle2 method1 again, we're going to get a different answer again, right? But they each have their own individual information, right? Each specific object has its own variable items information. Now what a static variable is pretty much like this method, right? This new method is a static method. It's always a variable in the automotive object. If I create static variable equals hi, right? What does this do? So now if I try to do self.static variable, that won't work because it's not a part of this object. It's not a part of an object really anymore. It's a part of this type of, I don't know what the other word would be naming it, and I think it would be called prototype, but I'm just going to call it a class. It would be a part of automotive. So the only way to access this would be calling it itself, automotive.static variable. Why is that? Unknown global automotive static variable. It's probably because we're in here. Actually want to try that. Is it going to error? Yeah, it errors. It's probably because we're in this function. But anyways, yeah, you can't specifically call it like that. Static variables are pretty much meant to serve as, if you wanted to access that, you would do automotive dot static var instead of saying dot new, and it gives you that that thing. That's interesting that I can't call it in this. Sorry, I put on my fan. Yeah, that is very interesting that I can't call it just normally. Unknown global automotive. That is very interesting. It's probably because we're in this function and the scope is a bit different. Yeah, that is a bit weird. Anyways, this information would only be accessed outside, not really inside the actual object. So how would you inherit now? So if we were to look back at our image, we had automotive in a car, right? Well, actually, let's do the motorcycle one, right? So we had speed. Well, in our automotive one, we had, let me delete that. Gas and speed. So we had borrowing gas, let's say it's equal to 1, and we had speed equal to 2. And then we had a start method. And let's just say print started. And then we had a stop method. Print stopped. Okay. So we have the start and stop method. That's pretty much simple. So now how do we inherit all from this? What we got to do is let's just copy this. Let's call this motorcycle. Right? Now, what we do here is we actually build on it. So what we would specifically do is we would create a local variable and we would call it automotive, or we can call it, you know, motorcycle equals automotive.new. Whoops, can't do local inside of that, sorry. And then what else is that inside of this new, I'm sorry, we're not returning an object like that anymore. We're actually doing this local, let's call it moto equals automotive.new. And then we add the properties onto that. We do moto.new property. Well, actually, let's look at what we did before. We still had speed and gas, but we had a kill switch method. So we'll just do kill switch equals function like that. We can still type in self in this. And then in the kill switch, we can do anything. Let's say the kill switch changes speed to 2. Self.speed equals 2. Oh, let's change it to 3, right? That's what that does. and then we return moto. This just basically inherits everything from this and then adds its own on. So now if I change this to motorcycle.new, right? And then I can delete that. If I were to print vehicle dot speed and then did vehicle kill switch and then print vehicle dot speed again, 2 and 3, as you can see, it inherits the speed variable, but it also adds in the kill switch method. But now, as we saw, we have specifically a cruiser one. So now we do the same thing again. Local cruiser is equal to an object, and then we say new is equal to a function, and then we'll say local motorcycle is equal to motorcycle.new, and then we add in the things again, and we'll return motorcycle here. And we said before we had a brand, so we do motorcycle.brand is equal to call it a Kawasaki. Did I do something? Oh yeah, named it wrong. What? I'm gonna rename everything actually too. Whoops, my bad. Motorcycle.new. Am I doing something wrong? Motorcycle.new. We have a new method here. Equals. Oh, I'm sorry. I think we were still in the table. We're not. We don't need that comma. And then you just return that. And then that has a brand. So now if I did motorcycle, we change motorcycle to cruiser, right? .new, and we try to do, we'll still have the kill switch. And we'll still just add on to this and then print vehicle.brand. Kill switch and nil value. Hold up. The cruiser. Turn motorcycle.new. Whoops, sorry. Right here, we wanted to return, actually, we wanted to return that. I messed up the variable names. So see, we still got the kill switch method that prints the 3, but we also have the brand property that has Kawasaki. Now, if I were to change this cruiser back to a motorcycle, you're going to notice I'm going to get a nil or error because we don't have brand on a motorcycle. We only have it on a cruiser. Now, the reason why a lot of this makes it simple is because you don't have to keep repeating functions all the time. You can just build from the top, which would be automotive, and then keep building down and down and down to be a little bit more specific. So if you ever wanted to add in a new type of motorcycle, maybe you want to add in the sports bike, you can just, get all the stuff from motorcycle and then create the object that's its own stuff. If you ever wanted to create a boat, you can just take it from the automotive and build down, and it just makes things more simpler. Yeah. Thanks for watching. Bye.